Hello, I'm Bülent, a PhD student at Naval Labs Europe and in Rio Grenoble. I will present you our work, Concept Generalization in Visual Representation Learning, which we did together with Yanis and Diane from Naval Labs Europe and Kartik from in Rio Grenoble. We consider the problem of learning general-purpose visual representations. In this paradigm, our goal is to train a model by solving a pretext task on a large-scale dataset, which is typically ImageNet-1K. After we train our model, we hope that it has learned high-quality visual representations, which are useful to solve downstream tasks on other datasets, each containing a possibly different set of images and classes. And the overall performance of our model on these downstream datasets determines the generalization capability of our model. Measuring this generalization has multiple dimensions, and one of them is concept generalization. In this scenario, we train our model on a specific set of scene concepts. Then we evaluate the representations learned by our model on a different set of unseen concepts with varying degrees of similarity to the seen ones. This way, we quantify the ability of our model to transfer its representations across concepts. However, there is no systematic approach for evaluating concept generalization using the common downstream datasets, because we don't know how the concepts in these datasets are semantically related to the concepts in ImageNet-1K. Therefore, it is not straightforward to determine which concepts are unseen at test time. Motivated by these issues, we propose a new benchmark, ImageNet-CoG, tailored for concept generalization. We built ImageNet-CoG on the full ImageNet-21K dataset, which allows us to select seen and unseen concepts from the same concept ontology, which is the WordNet ontology, where we have semantic similarity between concepts manually defined by linguists. To create ImageNet-CoG, first, we measure the semantic distance between concepts using lin similarity, which relies on the WordNet ontology for the concepts. As an example to lin similarity, here is the tiger cat concept from ImageNet-1K and 5 other concepts from the full ImageNet-21K sorted by their semantic distance to tiger cat. Then we generalize this pairwise lin similarity to sets of concepts and create 5 concept generalization scenarios. Each scenario consists of training a model on ImageNet-1K and evaluating its performance on a concept generalization level. Here, each level is a transfer dataset sampled from the full ImageNet, and they are arranged such that from level 1 to level 5, they contain semantically less and less similar concepts to the ones in ImageNet-1K. We also propose an efficient protocol to evaluate a model that is pre-trained on ImageNet-1K. Concretely, we extract image features for all the concepts. Then we train linear classifiers on each level separately and denote the performance of classifiers as the concept generalization capability of that model. To train linear classifiers, we divide the data for the concepts on each level into training and test sets, and train classifiers on the training sets, then evaluate their performance on the test sets. We perform an extensive analysis using 31 recent representation learning models. First, a baseline model, supervised ResNet 50, available in Torch Vision. Then we compare this baseline against the remaining 30 models that we put into 4 groups: the architecture group, the self-supervision group, the regularization group, and the data group. The outcomes of a subset of our experiments include the followings. Overall, we see that the performance of all 31 models monotonically decreases as we move towards semantically less similar concepts. Moreover, by comparing each group of methods to our baseline, we further observe that self-supervised models perform better and better as we move to L5, indicating that they are very promising for concept generalization. However, label-based regularization techniques perform worse on all CoG levels, suggesting that they might be overfitting to scene concepts. Please visit our poster for more results. To conclude, we propose ImageNet-CoG Benchmark for measuring concept generalization in a controlled way. The seen concepts are the concepts in the ImageNet-1K dataset, whereas the unseen concepts are sampled from the full ImageNet-21K dataset and arranged in levels which are increasingly challenging transfer datasets. This naturally makes ImageNet-CoG to be used out of the box for ImageNet-1K pre-trained models. Our evaluations revealed several interesting insights on popular state-of-the-art models. Please come to our poster to discuss them in detail.